Hi, welcome again for another video. So it's also based on multisim again, multisim software. So next, this video is going to deal with how the exclusive gates. If you see in the previous video that I have uploaded already, you know how many logic gates and ICs are there in total. So today we are going to see one basic detailed information about our exclusive gates. Okay, so exclusive gates are of two types, we already know. One is XOR, okay, XOR, and another is XNOR. So in the previous video we have already implemented that in the multisim, and we saw how the basic logic symbol for XOR and XNOR can be designed there, okay, how implementation can be possible, how the result will come serially. We can easily try to understand that from the previous video for sure. But if we try to implement XOR and XNOR, exclusive gates, okay, if we try to implement that using the basic gate logic, we can try to do that as well. Okay, so if we remember, our exclusive gate has representation like if equals to A XOR B. Okay, A XOR B. This was the Boolean expression for XOR gate, but XNOR was, let's say, T equals to X XOR Y whole bar. So if we remember the expression that we have done in the previous video, it was A B bar. Okay, I have just changed the variables, nothing else. Okay, nothing else, just the variables have changed. A bar B. Okay, so this was our expression. So if you want to implement this expression using basic gates, it can be done. Instead of doing XOR logic symbol again and again, if you remember the symbol used to look something like this, XOR. Okay, the symbol used to look something like this. But if we want to represent one XOR function in terms of basic gates, we can easily do it. So let's try to implement it here first. Okay, theoretically we will draw first. After that we will try to implement this circuit in the multisim software for today. Okay, so here we have A B bar, which means we need to make B bar first. So if we have A as our input, first input, we may take B as our second input. So now let's take B as complemented. Okay, if you want to complement any particular input, we already know that we can use NOT gate for complement operation. So now we have got our A B bar easily, isn't it? So we can use AND, because the relationship between A and B bar is multiplication, isn't it? So obviously it will be A B bar. So we have our first term, okay, A B bar, our first term created, okay, already designed. Next we need A bar, also we need B. So we can use one wire from here to make our B input, and we can use one wire from here. Okay, so we can take a wire from A, make A bar, because our expression suggests that it has to be complement of A. Okay, so now what are we supposed to do? We are supposed to make this in multiplied format. After that, you can see the relationship between the two terms, okay, is addition. So in order to implement this addition, we are going to use one OR gate. So after we have made our circuit, designed our circuit, we can easily write the output here. So this is how you can design one basic gate for this is how you can design one of XOR using basic gates. Okay, so now let's implement this circuit in the multisim software. Okay, so how you can do it, let me show you. Okay, this is the part of our given circuit that we are supposed to design here in the multisim. So let's do it. So we need two inputs here, so we are going to use place. Okay, just like the before video. So use sources. Okay, select digital sources. We have two inputs, A and B. So we are going to take A here first. Next we are going to take another input, which is B. Okay, so next we need which gate we need, let's check. Okay, we need one inverter to pass through this B. Okay, another inverter to pass through this A. So let's take inverter gates first. So in order to select the gate logic, we are supposed to select all groups. Okay, so from here, if you go through, we need inverter. So inverter, the IC number for inverter was 7404. Okay, 7404, this one. So you can easily collect it and place it nearby A, one inverter and another for B. Okay, two inverters we have already selected. So the next gate would be one AND gate. Okay, two AND gates actually. Two AND gates and another OR gate. Okay, so AND gate, if we remember from the previous video, AND gate was 7408. Okay, this one, 7408, this one. Okay, so you can select OK and place one AND gate for this particular circuit here. Okay, another AND gate, let's say here. Lastly, we need one OR gate, which was 7432. Okay, 7432. So we can easily search from here. It will take a little bit of time. I hope we can find it. We have found it already in the previous video. So yes, this one, 7432. So you can select OK and select the series you want, A, B or C, whatever. Anyone will work. Okay, lastly, just like the previous circuits, we are going to use one indicator. Okay, any color you like, let's say orange color. Orange is a bright color, so yes. Now we are just going to connect it. Okay, just connection. So let's take wires. You have first wire to be connected with this. Okay, just I'm implementing this circuit here. Next you have B. Okay, B is supposed to be connected with this first inverter. Okay, next you need to connect from the inverter towards this AND gate, first AND gate, and this first AND gate can be connected with OR gate. Okay, next we have here the inverter, which means you need to connect this inverter with A input. Okay, done. Next you need to connect one B input for our here. Okay, according to this connection, this one. Okay, we are just following this diagram for our connections, so I am showing you the diagram as well. Okay, I hope everyone can see that. So now we are just going to connect it and play the simulation. Okay, just play the simulation. So according to our XOR gate, if we remember our truth table, XOR was supposed to be activated only when we had unequal combinations. Okay, 1-0 combination, then XOR has to be high. 0-1 combination, also XOR has to be high. Okay, So let's take 0 1 combination. You can see the output is working perfect. Okay, it is showing high. If we take 1 1 combination, XOR gate is supposed to be low, isn't it? So it is showing low. 1 0 combination, XOR gate is high. So this is our first circuit. Okay, XOR representation, XOR gate, but using our basic gate knowledge. So after that we need to look for our next gate, which is XNOR. So if we want to do the same circuit, we can do it. Just apply one NOT here to make your XNOR gate. This is one way you can do it. Okay, just add one NOT gate to make XNOR, or you can also implement same operation just by applying the actual Boolean expression for XNOR. So what do we have here? We have AB as our input, not AB, sorry, the variables are X and Y for now. Okay, XNOR, the inputs are X and Y. So XY plus X bar, Y bar. Okay, so this is the Boolean expression that we are going to follow to make our circuit. So we can make XY first. Okay, this is our AND gate XY. Next we can make X bar. Okay, X bar. 1 minute. Let me write it. Okay. So inverter should look like a triangle actually. Okay. This is, my shape was not correct previously. So here we have X bar. Let's say X bar and Y bar. Okay. So these are the inputs. So now you need to make X bar and Y bar multiplication, which means you have Y bar already, but you need X bar. So make one inverter here. Okay. And then what you're supposed to do, you're supposed to use addition. Okay, addition. So this is how your final result T will come. Okay, just make sure you connect it accordingly. You can connect it you can connect in multisim. Okay, just draw the circuit and connect the gates, and you will get appropriate result. So the result for XNOR, if you remember the truth table, only for equal inputs. Okay, equal inputs, let's say X and Y both are 1 or X and Y both are 0, your result is supposed to be high. Okay, the light is supposed to glow up. So now we can continue here. So let's try the first circuit, which means just involve one NOR gate, inverter. Okay, one NOT gate. So let's do it here. So let's stop the simulation and delete this wire. Okay, remove a little bit, shift this output a little bit so that we can include one NOT gate here. Okay, let's copy and paste. I hope so. Yes, it is possible. You can easily collect the component from the component list, or if you want, you can just, I showed you one system. So now what we are going to do, just give simulation. Hopefully XNOR gate will work. Okay, in the previous video, if you see that we used XNOR for using logical symbols. Okay, just like any other logic symbol gate like AND or in the previous video we have seen, it was not working for XNOR. But if you want to implement XNOR using basic gates, it does work. As you can see, for 1 1 input, okay, 1 1 combination, you can see already the output is high. Let's take 0 1 combination. The output is supposed to be low, so it is low. This is for XNOR gate. So for 0 0 again, it is supposed to glow up. Okay, and for 0 1 1 0 combination also, you can see. Okay, 0-1 combination as well, it is low. So now this video was about implementation of XOR and XNOR gate using using basic gates, okay, and, or, and not. So now we can implement, okay, we can try to implement this circuit, this particular circuit, okay, in multisim. Okay, so let's do it. Let me shift it a little bit so that it is easily visible. Okay, this particular circuit we are going to implement here. So let's stop the simulation first. Let's place our inputs first. So inputs are sources, okay, so digital source number 1. Here we have digital source number 1. Next we have digital source number 2. Okay, next we have our, let's check for the gates. How many gates do we need? We need not gates like before, okay, we need AND gates also, 2 AND gates, 1 OR gate, and 2 NOT gates. So let's take it fast. Let's place our NOT gates first. So NOT gates you can find from all groups. Here you have 7400, you have to select for your first NOT gate. Okay, this one, NOT gate. NOT gate number 1 you can select here. Another NOT gate number 2 you can select here. So after the NOT gates are done, you can select AND gates, okay, AND gates. So AND gate was 7408, okay, so just select it. AND gate number 1, AND gate number 2. After the AND gates are done, we need one OR gate, okay, 7432. So we will search a bit until we get our desired IC, okay, 7432. Where is it? I'm unable to search it for now. So if I write it here, okay, so you can input the name of your particular circuit, particular IC, okay, particular component, and you will get, okay, you will get your circuit easily, and then place it. So lastly we need one probe, okay, so indicator, select any color, let's say red color, okay, and place it. So now since we have all our components ready, we can just join, okay, join our circuit work. So we can make XY first, okay, X is supposed to be connected here, okay, Y is supposed to be connected here, okay, XY. Next we need to make X bar and Y bar, okay, X bar and Y bar. So you can connect this from, let's say, X bar, okay, you can connect this one, let's say, from Y bar, okay. After that you're supposed to make X bar and Y bar multiplication, okay, so X bar, Y bar. Then after that we are supposed to connect the outputs from the respective AND gates through this OR gate, okay, so just connect, and that's it, okay. So now since our connection is done, okay, circuit connection is done, we can, okay, circuit connection will look something like this. So it is supposed to work as XNOR gate, okay, so XNOR gate, which means only for 00 or 11 combination the light is supposed to glow. So let's start with any other combination. Give simulation. You can see 1-0 combination. Okay, it is showing low output. So if we remember how we can make a truth table, you can see already G11. Okay, this one 11 is the input, equal. So XNOR gate actually exclusive NOR. Okay, XNOR exclusive NOR gate actually works when you have all the inputs as high or all the inputs as low. Then only your output XNOR gate is supposed to show high output. Okay, whenever you have equal inputs, then only XNOR gate is supposed to activate. So let's try it. Let's make 0 0 equal inputs. Okay, so here we can see equal inputs, the light is glowing. If we take 1 1, also the light will glow. But if we take 0 1 combination, the XNOR gate is not activated. Similarly, if we take 1 0 combination, the XNOR gate is not activated as well. So this is the end of our topic for today. We have just seen two gates, okay, two exclusive gates, how you can convert these two into Boolean format, Boolean expression. Already the expression how that can be derived is also explained in the previous video. You can go through that. And the truth table also I have explained there in a better way, so please go through that video as well. Previous one, okay, logic gate, the video titled as logic gate, you can just search. I have already uploaded, so you can learn from there as well, you can relate. So what we have done for today, we have just converted our Boolean expression into basic gate format. Okay, basic gate circuit design. This is for XOR and XNOR. So after we have I'm just repeating actually, so you can just go through, you can at least recall. So this was for our XOR, and the last one was our XNOR. Okay, so XNOR also we can implement into basic logic gates again, and according to the basic logic gates you can also make the truth table as well. So after you know how the exclusive gates will work, you can implement obviously here in the multisim software. Okay, so this gate also I will try this operation in the online version of multisim, which is multisim.com. okay, if you visit multisim, www.multisim.com, you will get one multisim live. Okay, this version is used for circuit designing, but live multisim circuit designing. Okay, you can easily do it, you can easily try. So I hope you have understood about this particular circuit designing. If you have any questions, you can ask me afterwards as well. Okay, I would highly appreciate your questions and discuss with you. This can be possible as well. Okay, please ask your questions. You can suggest me to make some similar videos regarding related, some Boolean expression. Okay, we can try it in the next upcoming videos. So I will try with some Boolean expressions like a plus b plus c, or maybe a plus b whole square, or something like that. Okay, any kind of formula, algebra formula. Okay, we can try algebraic expression, we can try. In the next videos, I think so it will be a nice suggestion. This is just one idea I have shared with you, so I will try it afterwards. So thank you for bearing with me throughout this video full time. So hopefully see you again, or you will get to learn again from the next video as well. So bye for now. Take care everyone.